Hello everyone. Hello everyone. Am I audible and am I visible to you? Let me just check it once. Am I audible Okay, so I'm live. A very good evening to all of you who are here with us today. So myself Isha Goel and I am your physics educator. I hope all of you are preparing well and doing a lot of hard work, putting in a lot of number of hours for your re-NEET examination, which is supposed to be held on 21st of June. So you hardly have 15 days for your exam, and we teachers at Deeksha Karnataka channel and even on the other channels of Vedantu, we are just trying to revise all the concepts and give you and discuss some questions with you to give you a good practice. So in our today's class, what we'll do is we are starting with modern physics, and within modern physics, so we started with modern physics yesterday. In the yesterday session we discussed dual nature of matter. In our today's session we'll primarily be focusing on the chapter atoms, right? And in our next class we are going to cover nuclei. So that is going to be our plan. And like as I always do, the same practice which I follow in most of my classes, we'll do the same today as well. That is, for the first 30 minutes we'll try and complete the revision of our chapter, and for the later 30 minutes of the class we'll try and solve some questions. So I hope you all must have also revised the chapter once. Even if you have not, we'll revise it from scratch. So before starting the video, there is a free initiative. There is a like absolutely free of cost initiative which is being run right now. That is Re-NEET 2026 Reloaded Crash Course. And the main highlight of this crash course right now is that it is being offered just for a fee of 0 rupees. So it is absolutely free. And you don't have to pay anything. You don't have to do anything to register for this. You will find the link in the description, link to this web page for this crash course. You will find it in the description. As soon as you click on the link, you will reach this page. You just have to click on buy now. And as soon as you click buy now, you will see it will ask you your mobile number and your basic details like your name and your parents' details. You just have to put in those details and you will be able to access the complete crash course. Now, what are the main highlights? You will be able to access all the digital study material, the PDFs, the assignments, class notes, all India test series, everything you will have at a single source. So it will help you in saving a lot of time. You won't have to run, for two different sources, to three or four sources. You will just get everything at a single place. Apart from that, you will also get in-class doubt solving, and you will also get a proper schedule of classes for all the master teachers. So do make sure to check out this crash course. You'll find the link to this crash course in the description below. Now, continuing with our topic today, which is atoms. So, the very first thing which you people must have studied in this chapter was your Rutherford model, your Rutherford experiment, right? You have also studied this similar chapter in your class 11th, like in your uh, second chapter of chemistry, which was structure of atom, right? So the same chapter was over there. The same topic was also there. We'll just revise it quickly. So in Rutherford's alpha scattering experiment, what did Rutherford exactly do is he just took a gold foil and he bombarded the gold foil with some alpha particles. So what did he do? Like the setup was something like this. Over here, he had a radioactive surface from where alpha particles were released, and then over here he kept the gold foil. This was the gold foil. Basically, gold foil was bombarded with some alpha particles. And then, when he bombarded gold foil with alpha particles, he observed a few things. So some of the key observations were like that most of the alpha particle, he bombarded many alpha particles on this gold foil, and out of all these alpha particles, most of these alpha particles just went through the gold foil undeflected. Like at whatever path or at whatever angle the gold foil, the alpha particle bombarded this gold foil, it just passed through the gold foil undeflected. So the very first observation was most alpha particle passed undeflected, right? And why am I writing these observations over here? Because for each observation, he had a conclusion. Like from every conclusion, for every from every observation, he concluded a certain fact about the atom, right? Then the second observation primarily was he observed that some of the alpha particles deflected, only some. Some of the alpha particles were deflected, and they were deflected by small angles, not by large angles. Most of them did not deflect. Then some of the alpha particles deflected by a very small angle. The third observation, what he observed was that a very small number, a very, very small number. And how small was that number? Like 1 in every 9,000. A very small number of particles, 1 in every 9,000 alpha particle, it just rebounded. What do we mean by rebounded? Rebounded means it just got deflected at an angle of 180 degree. Means the alpha particle came, bombarded the gold foil, and it entirely reversed its path and moved at the same path. It just rebounded. And that happened for a very, very, very few number of alpha particles. And then, like, these were the three primary observations which Rutherford saw. And pertaining to, corresponding to these three observations, he had three conclusions. He concluded that if most of the alpha particles are undeflected, this means that most of the atom is empty, because there is nothing concrete. Uh, if there had been something concrete inside the atom, then whenever the alpha particles strike the gold foil, they must have, bombarded some concrete thing, and that concrete substance would have deflected them. But since most alpha particles did not actually deflect, they passed undeflected, so he concluded that most of the atom is empty. Then from the second observation was that some alpha particles were deflected. So he concluded that only some alpha particles, and out of these some alpha particles also, only the particles, majorly the particles which bombarded the center, only those deflected. So basically he concluded that there is something concrete at the center of the atom. And later on, we got to know that this center of the atom was basically called as a nuclei, and it had a positive charge on it, right? The whole positive charge was concentrated in the center of the atom. Then from the third observation, like when 1 in 9,000 particles rebounded, a very less number of particles rebounded, he concluded that there has to be a very concrete thing which can actually deflect the particles by 180 degrees, which can actually rebound the particles. So this central core of the atom, it should be very, very, very strong, right? Then, apart from these two conclusions, these three conclusions, he also said that, in atoms, in every atom, the center the center has the positive charge and the negative charge, that is the electrons. Electrons will revolve around the nucleus. He said electrons should revolve around the nucleus. And along with this, he also said that anything which will keep on revolving, it will radiate some energy. It will radiate some energy. And this is where the main problem arose. This was the main problem. Why was this a problem? Because according to Rutherford, then if electrons would have been revolving around the nucleus, and they would have been, and any moving charge is radiating the energy, then according to this logic, each and every electron would have to fall inside the nucleus after some point of time. But that actually does not happen. Electrons keep on revolving around the nucleus. none of the electrons actually fall off in the inside the nucleus even after many years. That was not the case. That will not happen at all, right? So this was the main limitation of Rutherford's model. Rutherford was not able to clearly explain with proper reasons that why electrons should revolve around the nucleus and why should the electrons not be revolving in the fixed orbits, right? Then moving forward, he also did two things. So there were two formulas which you saw. First was the formula for distance of closest approach. Closest approach simply meant that over here, this is the center, this is nucleus. Nucleus total has Z into E amount of charge. Z is basically the atomic number and E is the number of electrons. This was the distance of closest approach R naught. And we said that alpha particle has twice of electron. The charge on alpha particle is twice of electron. When an alpha particle was coming with some velocity u, it has a mass m, it just rebounded from here. It actually did not strike. So what will be this minimum distance? What will be this distance of closest approach? So this distance of closest approach, the formula for this was 1 upon 4 pi epsilon naught 2 z e square by half m u square. Half m u square is basically the initial kinetic energy, right? This was the distance, this was the formula for distance of closest approach. And then there was something called as impact parameter. Impact parameter, it basically was that this distance b, this is the particle which was rebounded, this is this particle which rebounded back 1 in every 9,000, and this was the other particle which actually deflected by some angle. So impact parameter is the perpendicular distance between the particle which rebounded and the very first particle. Like we leave a particle over here, we throw a particle over here, none of these particles deflected, but this particle is the very first particle which got deflected by some angle. So this distance was impact parameter, the perpendicular distance between velocity vector and the alpha particle from the center. And the formula for this this impact parameter was 1 upon 4 pi epsilon naught z e square cot theta by 2 divided by half m u square. And theta was actually the angle by which the particle got deflected. So this was called as impact parameter. Impact parameter. Okay. This R naught was distance of closest approach. These were the two main formulas. And then we already discussed the drawback of your Rutherford's model. He was not able to explain the revolving of electrons around the nucleus, and then he also stated that electrons will continuously radiate energy and at the end they will fall off in the nucleus. Then came Bohr. So Bohr was basically able to justify this reason. And how was Bohr able to justify or correct this drawback of Rutherford model? Bohr said that instead of Rutherford basically suggested this is the nucleus, electron is revolving in this nucleus, electron will keep on revolving and at the end it will fall off inside the nucleus. Rutherford said that this won't be the case. Why? He gave some postulates, and out of those postulates the main reason which was able to justify this drawback was, he said that electrons will revolve around the nucleus, but these electrons will revolve around in fixed orbits. And what do we mean by fixed orbits? Fixed orbit means energy of each of these orbits, if I say E1, E2, energy of each of these orbits in which the electrons will revolve will be fixed. It will be a very particular and a very specific value, and any electron revolving inside or in the path of a fixed orbit, that electron will not actually radiate any energy, right? So the very first postulate of Bohr's atomic model was that electrons will revolve around the nucleus in fixed orbits. and any electron inside these orbit will not radiate any energy. So electron will not fall off in the nucleus eventually. It will be there in its fixed orbit. Then the second postulate which Bohr suggested was that these orbits will be called stationary orbits, and every electron revolving in these orbits will have a specific angular momentum, and that angular momentum will be an integral multiple of h by 2 pi. Integral multiple, so we multiply n h by 2 pi, angular momentum. And this formula was called as Bohr's quantization condition. Bohr's quantization condition. Okay. This was the second postulate. Then the third postulate of Bohr model was that he said that the central core of the atom is very small and very massive. Massive in the sense that the charge density for that central core is quite high. And that central core was then named as nucleus. And then the last postulate which Bohr said was that the energy is radiated when an electron, energy will only and only be radiated whenever electron will jump from one orbit to other. For example, if an electron is here in the second circle, second orbit, and from this second orbit electron jumps to this first orbit, only and only in this jump some energy will be radiated. Some energy will be radiated. Otherwise, if the electron is revolving in its fixed orbit, then no energy would be radiated. The case might be reverse as well. Electron may jump from first to second orbit as well. But that won't radiate any energy. That would actually require some energy. Okay. So these were the Bohr's postulate. Now coming to the Bohr's theory, the first and foremost thing which you have to remember, especially from the point of view of numericals and your NEET exam, is that you have to remember that Bohr only and only did everything, every research, every formula, whichever formula he gave, he only and only gave it for hydrogen. For hydrogen-like species, the formula was not given by Bohr. Okay. So from Bohr's theory of hydrogen atom, we saw some formulas. So I'll just straight away write the formula. I'll not delve deep in the the derivation of those formulas and how we actually got them, but I will just write the formulas for your reference. So the very first formula was for the velocity of electron, velocity with which the electron was revolving in the nucleus. The velocity was nh by 2 pi m r. This was the formula for velocity. Then the next formula was for radius of the orbit, radius of the orbit in which the electron was revolving. So, this Bohr also said that electron can't revolve in any orbit. It can't be the case that, for example, if this is my nucleus, this is the first shell which I created and this is the second shell. Then if I have drawn the second two shells, there can't be any other third orbit between them. Why? Electrons will only and only revolve in those orbits in which their angular momentum is an integral multiple of h by 2 pi. So we were basically able to fix the orbit. We were able, like Bohr actually was able to fix the orbit, that which particular orbit can exist and which particular orbit cannot. So the second formula was for the radius of the orbit. The radius of orbit formula was n square h square divided by 4 pi square k m e square. So what you have to remember, you don't have to remember the entire formula. You just have to remember the relationship with each variable which is on the LHS. Like for example, we have V in the first formula, R in the second formula. You just have to remember the relationship of these with N. N is the number of shell. For example, if I say I'm talking about first shell, then I'll keep the value of N as 1. If I'm talking about second shell, I'll keep the value of N as 2. So I can see velocity is directly proportional to N, radius is directly proportional to square of N. So if someone asks you to draw a graph between radius and N, number of shell, then it will be a parabola. It will be a parabola. And the relation between the graph between V and N will be a straight line because V is directly proportional to N. These were the two important formula, right? And then the last formula was for energy. So the formula for energy was basically minus 13.6 upon N square in electron volt. So whenever you use this formula, you will always get the energy in electron volts. If you want to convert it, then you will have to multiply it by the charge on one electron. So these were the three main formulas which Bohr gave us. Then we were also able to apply these formulas to hydrogen-like species. What do we mean by hydrogen-like species? Basically, any species, any ion which has one electron. So we know hydrogen has one electron and one proton, right? So hydrogen-like species means any species which only has a single electron. For example, if I write He plus, atomic number of helium is 2, and then from out of 2 electrons, it has a positive charge, so it has lost 1 electron. So He plus, then if I say Li2 plus, atomic number of lithium is 3, Li2 plus has 1 electron. Li2 plus and so on. Like these were called as hydrogen-like species. Any species which has only a single electron, only one electron. So we can also apply these formulas to hydrogen-like species. We just need to multiply with Z. Then the next main thing which Bohr also suggested was the spectral series. The spectral series. Spectral series was basically the last postulate which we discussed. The last postulate stated that whenever the electron will do a transition, this is the nucleus, this is first orbit, this is second orbit. Whenever an electron will do some transition, let's suppose from second to first orbit or from first to second orbit, this electron will either radiate, means either release, or it will require some energy. So in case it is radiating or releasing some energy, how will we calculate that value? In case it requires some energy to jump from one shell to other, what will be that value? How will we actually able to calculate? So in our yesterday's class in dual nature of matter, you people must have studied that energy of any photon or any packet of energy. If we want to find out the energy, we can use the formula hc by lambda or h into nu. Nu was the wavelength, then wavelength is c by lambda. So what Bohr did was he gave a formula for 1 upon lambda, that is, and this is called lambda, and we put a bar over lambda. It basically means wave number. So he just gave a formula for wave number, and wave number we can find out, that means simply reciprocal of wavelength we can find out by r into 1 upon nf square minus 1 upon ni square. R was basically Rydberg constant, and the value of Rydberg's constant was 1097 into 10 raised to the power. So like I'll just write the complete value. 10, the value of Rydberg's constant was 1.097 into 10 raised to the power 7 meter inverse. So this was the value of our Rydberg's constant. You just have to put the NF is basically the final shell, the number of final shell. For example, if I say electron jumped from n is equal to 2 to n is equal to 1. So NF, the value of NF will be 1, value of Ni will be 2, because initially electron was in the second shell, so N is equal to 2. Finally, the electron is in first shell, so N is equal to 1. We just need to substitute the value of NF and Ni in this formula and we'll get the reciprocal of wavelength. Now, what is the advantage of getting reciprocal of wavelength? We can see if we multiply this reciprocal of wavelength by h into c. H is Planck's constant, c is speed of light in air, 3 into 10 raised to the power 8. You will directly be able to calculate the energy. You won't have to, take the reciprocal of wavelength and then find out. So you have to just read the question with very much concentration. Many a times what happens is you're just asked to calculate the energy. So, and a lot of students, what they end up doing is they end up finding lambda. So they take the reciprocal and then the calculation becomes lengthy. Actually, the calculation of lambda is not even required. If you have 1 by lambda, simply multiply it by h into c. Now spectral lines, there were five series. So first was Lyman series. You can just take a note if you're not aware. So first was Lyman series. Lyman series, whenever the electron jumps from any higher energy level to first orbit. That means the final value, the value of NF when it's 1. Any higher energy level to first orbit, to first energy level. This is Lyman, and whenever the electron jumps from a higher to a lower energy level, it will always radiate energy. And the radiation which will be released over here whenever electron comes to the first energy level, that radiation will fall in ultraviolet region. Ultraviolet region, UV region. Second was Balmer. Balmer series, the final shell will be 2. Whenever the electron jumps from any higher energy level to second energy level, to second shell. And in Balmer series, the radiation basically lies in visible region. In visible region. Then third was Paschen. Paschen series, final energy level has to be 3. Paschen, Lyman, Balmer, Paschen, bracket and Fund. Bracket and Fund. So in bracket, final orbit should be 4, and in Fund, final orbit should be 5. And for all these three, for the below three, like Paschen, bracket and Fund, for all these three, the radiation lies in infrared region, IR. The spectral series, the radiation which we get, it will lie in infrared region. So most of the questions will come either from here or from the formula of energy which we wrote, minus 13.6 by n square. Mostly question either comes on energy of atom, energy of first orbit, second orbit, third orbit, or from spectral series. So this was the spectral series. And then I think you people must be aware about excitation energy and excitation potential. So excitation energy is basically the energy required to raise the electron from ground state to any excited state. Yeah, and you guys also have to remember that whenever the electron is in first shell, whenever the value of n is 1, this is basically called as ground state. This is basically called as ground state. And any value of n, that is any orbit other than the first orbit, that means n is equal to 2, 3, 4 and so on, these orbits are called excited state. And most important point which you have to remember is n is equal to 2 is your first excited state. First excited state does not mean that the value of n is 1. First excited state means the value of n is 2. Then this is your second excited state, this is your third excited state, and so on. Just remember this very carefully. First excited state means n is equal to 2, the value of n is 2. Second excited state means the value of n is 3. Ground state means value of n is 1. So many a times what they do is they don't actually tell you the number of orbit or shell number. Instead, they tell you the second excited state, third excited state or ground state. They'll use words like these. So don't get confused by that. Then excitation potential, it was basically the potential difference through which electron has to be accelerated to raise it from the ground state to any excited state. Energy to raise from ground state to excited state is excitation energy. Potential difference to accelerate the electron from ground state to excited state is excitation potential. Then ionization energy is basically the energy required to remove the electron completely from an atom. We just need to remove it completely. Then it is called ionization energy. Ionization potential, again the potential difference through which electron of an atom is accelerated to knock it out or to release it from the atom. So this is all about our chapter atoms. In case you have any doubts, you can post your doubts in the chat section. I'll just take 1 minute and like wait. If anyone has any doubt, you can post in the chat section. Otherwise, we'll continue with our questions. Okay, so I suppose there are no doubts. You're clear. So, like, we are done with the revision of our this atoms chapter. Now, before moving to the questions, even for much more practice, like we always do questions in our classes, but as the time is limited, so we can't actually do many questions within the class. So for your practice, what we have done is that we have released a Vedantu NEET AITS 180 test series. And within this test series, you people are getting 3600 plus MCQs, 20 mock tests, 20 tests in total, if you see over here, with along with 25 OMR sheets. Out of those 20 tests, 12 tests are full syllabus and 8 mock tests are of part syllabus. Along with this, you're also getting 3600 plus MCQs, which are categorized in different papers, right? And we also have, and this test series also consists of complete answer book. It does not like, it's not the case that we're just giving you the exam papers, or we're just giving you the mock tests. We are also providing you the answer booklet for each of these practice papers. You will find out the link in to this test series, to this book, in the description below. Do make sure to check it out. Okay, and I also talked about this Re-NEET Reloaded crash course in the beginning of the class as well. So this is a free crash course which is being offered right now for Re-NEET 2026 exam. It is absolutely free of cost. You don't have to pay anything. You don't have to do anything. Only and only you have to visit the web page and just click on buy now, and you will be able to register for free. Now moving to the questions. Sorry, moving to the questions. So I have around 10 questions. So this is your first question. What we usually do in our classes is, I'll just show a question on the screen. I'll give you 1 to 2 minutes. If it is a calculation heavy question, then I'll give you 2 minutes. If it is a theory based question, then I'll give you 1 minute. And you have to post your answers in the chat. And after that 1 minute is over, you have answered the question in the chat, we'll discuss the question. Only then you will be able to like get a good practice. So your 1 minute starts now. So I'll just give you a hint. The question is basically saying that in the first excited state. So what should be the value of n for first excited state? First excited state basically means the value of n is 2. We're talking about the second orbit. In this first excited state of hydrogen atom, the energy of electron is minus 3.4 eV. Radial distance of the electron from the hydrogen nucleus in this case is approximately. You need to find out the radial distance. Radial distance means, what do we mean by radial distance? Can anyone answer in the chat? Radial distance basically means your radius. Is anyone able to calculate the answer? Can I see some answers in the chat? Like, you just need to type the option. You don't need to write the complete answer. You can just write A out of A, B, C, D, which option you feel is correct. Or what is the answer according to you? Okay. Now we'll discuss this question. So you just have to find out the radial distance. So we can just simply use the formula k q square upon 2r is equal to minus 3.4 ev, the same formula which we used yesterday. So sorry, not yesterday, the same formula which we revised a while back. So if we put in the value, k is basically this constant. This constant is, you must have studied this in your electrostats as well. This k is 1 upon 4 pi epsilon naught. So value is 9 into 10 raised to the power 9 multiplied by the charge. Charge on one electron is 1.6 into 10 raised to the power minus 19. The square of this divided by 2 into this 2 into 3.4. Minus sign basically states that, minus sign basically states in the energy that it is bounded to the atom. Electron is still bounded to the atom. As soon as the energy of a electron becomes positive, the electron will no more be bounded to the atom. Because the energy is in ev, so we have to multiply this 3.4, this energy, with charge on one electron. Okay, so 1.6 into 10 raised to the power minus 19 gets cancelled out with this square, and you can just cancel 1.6 from 2 to 0.8. You get 0.8 and 3.4. We can just remove the decimal, and when we simplify, we'll get the answer as 2.11 into 10 raised to the power minus 10 meters. So over here in all the options, the answer is same, 2.1, and the only the powers are different. So power we got is 10 raised to the power minus 10. That is option number C. So for your competitive exam, be it any competitive exam, not just NEET, what you have to do is, in addition to the hard work which you are doing, you also have to do some amount of smart work. And what do I mean by smart work? Had it been that the values of all these options, the values in all these options have been different, then I should have calculated the complete value, because a lot of my time will get wasted in calculating this 2.1. Because I already saw that all the options have 2.1 and only the power is different. So what I'll do, wherever I see, as soon as I am able to reach a single digit number by multiplying or dividing some of the constants, as soon as I am able to reach this single digit number, I'll just leave it aside, I'll keep it aside, and I'll just focus on calculating the power of 10. So this is one of the tricks which you should always remember for every or any competitive exam you have to give. Apart from this, I would say, like, this technique worked for me as a lifesaver, especially in the last 30 minutes of the exam. If God forbid you are not able to solve like a good number of questions and you start panicking, and sometimes what happens is, like, usually out of the 4 options you are able to eliminate 2, but the main confusion lies amongst the 2 options. So what you can do is, you can also try substituting the value from the option in the question and then check. Like, instead of coming to the answer, you can put the answer and try reaching the question. So you can also, apply the reverse path and then reach the correct answer. And you can specially follow this trick if in those questions in which you are confused between the 2 options. Moving forward to the next question. You have 1 minute for this question. This is a straightforward question wherein you have to tell the relationships. That how does mass F, you're given the force, how does the radius depend on value of n. I'll just give 1 minute of time to you guys and then we'll discuss it. Any answers? Like, don't be scared of, answering wrong. Your answer might be wrong, not a problem with that. But at least you should gather and you should have the courage of typing the answer. I'll also know that you are solving the questions actually. And if you don't even like, if you don't solve the question from the fear of, arriving at a wrong answer, then I would say like it will not benefit you, because when you solve the question, only then you will be able to understand where you committed a mistake. So don't fear from answering or don't fear from solving the questions. Okay, so can I have some answers in the chat? Anyone? Just need to type the option A, B, C, D. I'll just give a hint. You have to think along those lines that whenever a particle is moving in a circular track, which force works in circular path? Why am I saying circular path? Because this is the nucleus and this is a orbit and this is a electron. This electron is revolving in this orbit. So you have to just think along those lines that which force will keep this electron in a circular orbit, or not this electron, which force keeps anything in circular track? What is the name of that force? Can anyone tell me? In a circular path, what is the name of the force that keeps any object going on in a circular path? Yeah, you can post your doubts in the chat. I'll discuss that. Can anyone tell me the name of the force which keeps an object in a circular track? Centripetal force. And this centripetal force is given by formula mv square by r. Just remember laws of motion. The centripetal force is mv square by r. Over here, the question is saying that a particle of mass m, mass of the particle is given m, and then is moving around the origin. A particle of mass m is moving around the origin with a constant force F, pulling it towards the origin. The particle, it is pulling it towards the origin. If Bohr model is used to describe its motion, you have to tell the radius of the nth orbit and the particle's speed v in the orbit depend on n as. We just need to tell the relation between the basically the radius and n and velocity and n. So centripetal force formula is mv square by r. This is equal to F. If I see mass of the particle is constant, so then I can say, and we are also given that force is constant, right? Constant force F. So v square by mv square by r is a constant, and in this mv square by r, m is also a constant. So I can say v square is directly proportional to r. I just got v square is directly proportional to r. Then I also know that electron will only revolve in those orbits in which the angular momentum is quantized. That is mvr is equal to nh by 2 pi. So from here we can say when we try to solve both these questions, both these equations simultaneously, we will get that velocity is directly proportional to n raised to the power 1 by 3 and radius is directly proportional to n raised to the power 2 by 3. You just need to solve these two equations simultaneously, nothing else. Like you can just substitute r as some constant times v square over here, and then you will be able to get this thing. Okay. So velocity is directly proportional to n raised to the power 1 by 3. Radius is directly proportional to n raised to the power 2 by 3. So option number A is our correct answer. Option number A is our correct answer. Moving forward to the next question. This is a very straightforward question. We just discussed this. The question is just saying that the spectral series which correspond to electronic transition from levels where the value of n2 is 5, 6, and then the final orbit is 4. That is, from any higher excited state, the electron is finally coming to fourth orbit. So what should be the name of our series? We just discussed this. Can anyone tell the answer? The series start from Lyman, Balmer, Paschen, Brackett, and Fund. Yeah, so answer is Brackett. Lyman value is 1. All the electrons come to first orbit. Balmer value is 2. Lyman, Balmer, Paschen is not here in the options. Paschen has n is equal to 3. Bracket n is equal to 4. And Fund is n is equal to 5. Moving to the next question. So I'll give you 2 minutes for this question because you need to read both the statements and then come to the conclusion that which of the statement is true, which is false. Any answers for this question? Yes. So the correct answer would be C. Yeah, good. Correct answer. Quantum XP. Yeah. Correct answer option C. So we'll just read the statement. Statement 1 says atoms are electrically neutral as they contain equal number of positive and negative charges. So this statement is entirely correct. This is completely correct, right? Atoms are neutral because atoms has, for example, if I say helium atom or lithium atom or any other atom for that matter, all the atoms are electrically neutral. But if we read the second statement says that atoms of each element are stable and emit their characteristic spectrum. What do we mean by that? Statement is saying that atoms of each element are stable. Every element has a stable atom and every stable atom will always emit a characteristic spectrum. Now this is incorrect. Why is this incorrect? Because it is not necessary that each atom will release a characteristic or will emit a characteristic spectrum. Why? Because like every atom will not emit the spectrum. Only and only when an electron is excited, it jumps to an excited state, and then while coming back from excited state to its normal state, only in that case this atom or electron will emit the spectrum or emit the energy. So first statement is correct, second statement is incorrect. Moving forward to the next question. The question is just asking you that the ground state energy is given to you. Ground state means n is equal to 1. Question is saying the ground state energy of hydrogen atom is minus 13.6 eV, and the energy needed to ionize hydrogen atom from its second excited state. Second excited state means n is equal to 3. You just need to find out the energy for n is equal to 3. Formula was minus 13.6 by n square EVs. So minus 13.6 by 9. 3 square is 9. When you calculate this, this will come out to be 1.51, minus 1.51 EV. So this is the required energy, and the question is asking energy needed to ionize it. So it will be reverse sign. So option number C will be your correct answer. Moving to the next question. Any answers for this question? Question is basically saying in hydrogen spectrum, the shortest wavelength in Balmer series is lambda. And you are asked to find out the shortest wavelength is bracket. So how can we do that? Basically, you are given that in hydrogen spectrum, shortest wavelength in Balmer is lambda. So in Balmer series, where does the transition finally happens? In Balmer series, we just saw the transition. Any electron coming from any higher excited state, it will come to n is equal to 2. That is the second shell. So if we consider the transition is happening from infinity to 2, then for Balmer series, the wavelength is lambda. So that means 1 by lambda is equal to r into 1 by 2 square minus 1 by infinity. If I am assuming the transition is happening from infinity to 2. So this will come out to be 1 by lambda is equal to r by 4. I don't need to put the value of Rydberg's constant because that will eventually get cancelled. Then we were asked to find out the shortest wavelength. Why am I taking from infinity? Because shortest wavelength will only come when your initial state is infinity. Otherwise, the value of wavelength will not be shortest. Then you are asked to find out the shortest wavelength for bracket. For bracket, the final energy level is 4. So r into 1 by 4 square minus 1 upon infinity, 1 upon infinity becomes 0. This is r by 16. When we divide both these equations, r gets cancelled with r, 16 goes above. This becomes 4. So lambda dash upon lambda is basically 4. So lambda dash is basically 4 lambda. So option A will be my correct answer in this case. Moving to the next question. This is also a straightforward formula based question. You can use the same formula which we discussed for radius. The formula was simply radius was directly proportional to n square. So you can just assume that there is some constant r naught n square, and the value of this r naught is already given to you in the question. Radius of innermost orbit of hydrogen atom is given to you. Innermost means when n, the value of n is 1. So that is already given. This value is 5.3 into 10 raised to the power minus 11. And you are asked to find out the radius of third allowed orbit of hydrogen atom. That means the value of n should be 3. So you just need to multiply it with the square of 3. That is 9, 5.3 into 9 into 10 raised to the power minus 11. When you do this, 9 3s are 27, 9 5s are 45, 47. 47.7 into 10 raised to the power minus 11. And you can then place, so this is in meters. So then you can convert it, and after conversion, I'll see you'll get option number C as your correct answer. Moving to the next question. For this question also, you have to use the same formula which we just used in the above formula. So you are given R1 be the radius. You have to assume R1 be the radius of the second stationary orbit. Second stationary orbit basically means n is equal to 2. R2 be the radius of fourth stationary orbit. Fourth stationary means n is equal to 4. Of an electron in Bohr's model, you have to find out the ratio of radius. Radius we just saw, radius is directly proportional to n square, or even if we take r naught into n square, then r1 will be equal to r naught into 2 square. R2 will be equal to R naught into 4 square. When we divide both these equations, R naught gets cancelled with R naught. We are left over here on LHS, we get R1 by R2. On RHS, we get 2 2s are 4 and 4 4s are 16. So we get 1 by 4. 1 by 4 is 0.25. Option B. Moving to the next question. So so this is the last question for today. This is your last question for our today's class. Okay, so I'll discuss this question. You are given, let T1 and T2 be the energy of an electron in first and second excited state. First and second excited state means for T1 value of n is 2, first excited state. For T2 value of n is 3 because second excited state. You are given, and T1 and T2 are the energy. You need to find out the ratio of T1 and T2. T1 is to T2. For energy, we saw the formula. Energy is basically inversely proportional to n square. Inversely proportional to n square. Even if you take some constant, let's suppose E naught. So T1 should be equal to E naught upon 2 square. T2 should be equal to E naught upon 3 square. And when I divide both these equations, E naught gets cancelled with E naught. On LHS, I am left with T1 by T2. On RHS, I get 9 by 4. So my ratio comes out to be 9 is to 4. Be very careful in choosing your answer because we also have 4 is to 9 in one of these options. So this was our last question for today's class. Before closing for the class, before ending the class, I'll just like to remind all of you that there is a free of cost crash course which is being run right now, and it's called Re-NEET 2026 Reloaded Crash Course. You can find out the link for this crash course in the description below. If you scroll down on this page, you will see a fees of 0 rupees. It is just absolutely free for you people. You just need to click on buy now, and it will ask you some basic details like your mobile number and name and parents name. The second initiative which is being run right now is the Vedantu NEET AITS 180 test series. It is designed by subject experts, and it is curated specifically for your NEET examination. Within this test series, you are getting 3600 plus MCQs as well as 20 mock tests. Out of those 20 mock tests, 12 mock tests are full syllabus and 8 mock tests are part syllabus. You can also see some of the questions, like they also have offered a preview. So you can also see the preview of this test series before buying it. But do make sure to check both these things out, and it will definitely help you a lot with your preparation. So thank you so much for watching our today's video. Thank you so much for attending the class. See you in the